Knox Game Design, April 2023, Deconstructing Falling Blocks.
Welcome everyone to Knox Game Design for April 2023. My name is Levi Smith. So this month I'm going to be talking about destructing a falling blocks line clearing game. Anyone who's had the old Game Boy from the early 90s has probably played a falling blocks line clearing game. I'm going to try to avoid saying the T word just because I know that's like copyrighted or trademarked, something like that. So just calling it the falling blocks game. And yeah, I may turn this into like a series. I know I've kind of talked about many different game engines and frameworks and tools, but really haven't went into like actually how to create different types of games or destructing games. So this is going to take a game that a lot of people know or a lot of people are familiar with and show what goes into making that type of game. So yeah, this is going to be a very simple implementation of a falling blocks game. I'm going to use examples, or to use one example in MonoGame. I picked MonoGame because it's fairly easy to set up, fairly easy to get a game running in MonoGame. So I'm going to be using examples in that game development framework environment, which uses the C# programming language. If you need any help setting up MonoGame, I have a talk from, I think it was a couple of years ago. Can't remember which month it was, but just search MonoGame on the Knox Game Design website. So yeah, the requirements, you just need Visual Studio. And here it is right here, Knox Game Design, September 2020. You can refer to that if you need any assistance setting up MonoGame. You can use other game engines such as Game Maker, Allegro, SDL. That's something I wanted to do, is like actually implement this in many different languages. I just don't have time to do that. You also need a simple graphics editor. We're only going to be using 2 sprites, so it really doesn't have to be complex. I did put some examples: GIMP Paint, Aspirite. I'm not sure if I spelled that correctly, or any sprite editor. So yeah, the first thing you'll need to do is to create 2 sprite PNG images. I think I'd use 32 by 32, so one's just going to be a black empty square and one's going to be a white filled square. So that's going to be our block that we're going to move around on the board, and also the image for showing all the blocks on the board. So the first thing you want to do is you just want to make sure you can display one of your sprites on the screen. So I kind of went in here and for all the code that comes default when you create a MonoGame game in Visual Studio, I sort of highlighted what you need to add. So I always like doing a dictionary of strings to textures that holds all the sprites that you'll be using. And so I create in the load content, we're going to create a new dictionary object, and we're going to have 2 indexes, block underscore empty and block underscore filled. So block empty is just going to be the empty block, and the block filled is going to be the block in the white square. And down here in draw, we're just going to do sprite batch begin, then sprite batch draw. We're just going to draw the empty block at 0, 0. We're going to make it 32 width by 32 height. And this color I is just, this is cut white, is just the tint. So we're just going to make that white so it retains its original color. And then we're going to call sprite batch in. So we should get like this cornflower blue screen with a black square in the upper left hand corner. So I do have Visual Studio open with this code already loaded, so we're going to run this and we get our cornflower blue screen, default screen with the black block in the upper left hand corner. And I will just go ahead and mention, so there's this content MGCB. I think this used to be more difficult to set up, but it's pretty easy now. You just go in and you add existing content items. Let's see, you use that plus right there, add an existing item. Then you can go in there and select your block empty and your block filled right there. Yeah, so that's the first step whenever you're making a game, is just get a window to open, or if it's a web game, just get something to display on the screen. It's just getting something to display on the screen. That's always step number one before you do anything, before you start like writing game logic, coding game logic, or anything like that. So the next step is setting up our board. So we're going to use a M by N array. So the typical old-fashioned falling block line clearing game uses 20 rows by 10 columns. It can be one of many data types. If you only wanted like just have whether it's a block or not, you can use booleans, but it seems like a lot of times booleans are kind of hard to work with because you're having to type out true and false and all that. I like doing ints, and that's what I'm going to use in this example. So an int can hold like a value for a color index. So if you want to have different colored blocks on the screen, that can be represented by the ints. Or you can actually have an array of objects. So they can all be null, and then as you add blocks to the board, then you just put in references to each of the blocks. So that works out pretty well, like if you're doing Unity and other things like that. You can actually take the blocks from your current piece and just move the reference onto the board. You should store the maximum number of rows and calls as a constant or a variable. I won't be doing that, which is bad in this example, but I'm just trying to keep these examples simple and easy to understand. So the next thing you need to do is learn how to just figure out how to draw the board to the screen and resize your display if needed. So this is what it'll look like. So actually, our black empty box I actually put it like a gray outline, so I actually see a grid, 20 rows, 10 columns. This shows where you have the array for the board. And initialize, we're going to set our graphics to 320 by 640. That's, I believe 32, 32 times 10 for the width. Oops. 320. 20 times 32 pixels for the height, which is 640. Then we're going to do this graphic supply changes. Again, that's specific for MonoGame. And then we're just going to leap through all the rows and all the calls, or initialize the board just to all zeros, meaning there's no blocks. And then our draw, we're going to loop through all the rows and calls again. And if the board, if the cell value is 0 for that index, we're going to draw the empty block at that location. Or if it's filled, we're going to draw the filled white block at that location. So I kind of have this, I'll post all this code out to the code repository. So I kind of have this broken up into different steps, so you can load each step as this is being built. So this one will have like the new size and the rows. So if we run this, then you see the resized game board right there. So it doesn't do anything, but it displays our game board. So it's the start. It's like the first step after just making sure you can draw something to the screen is to draw the game board. So in our falling block game, we're going to have a piece that's going to contain 4 blocks, made up of 4 blocks. And we want to move that piece horizontally left and right. So our piece, actually I changed this to a 5x5 array just because when we're going to rotate the piece, it's easier to do it on a 5x5 array, which has a defined center. So we're going to need 2 ints for the row and column position of our block that we're going to move around, our piece. So I'm using block as a specific square and a piece as the combination of those 4 blocks that we're going to move around. So we should probably load the piece data from a text file. I'll talk about the different pieces a little bit later on, but that's just going to be coded as an array for now. But we're not even worrying about the different pieces right now. We're just working with one piece. We're going to start out like here, start with the simple shape. I'm going to start out with the T shape. Then we want to draw that piece to the screen. So here's the example. We got current piece as a 2D array, and there's our T structure right there. I'm going to mention that this is actually upside down because our rows are going to go from vertically from 0 at the bottom to 20 at the top, or 1 at the bottom to 20 at the top. You can either go from 0 to 19 or 1 to 20. It's all up to how you decide to code it. So yeah, if you're going, and obviously in most game development environments, your screen coordinates go from 0 at the top, 0 pixels at the top, to the screen height, or window height at the bottom. So it's going to be inverted. So we're going to loop through all the values in the current piece, and we're going to draw, if it has a block, which is represented by 1 right here, we're going to draw that block on the board, on the screen, at the row and column position for that block in the piece, plus the current row and column of the position, the control position of the block by the player. So you're going to be able to move this piece left and right. Always be aware that you always usually refer to these as row and then column, but when you're drawing, row is going to be the Y in the Y position, the Y coordinate, and your column is going to be in the X coordinate. So it's kind of flipped because whenever you draw a rectangle, you always specify X first and then Y. So you'll be drawing the column position first, then the row. So just be aware of that. So let's go back to our examples. So this is going to be following blocks 4. Run this. So yeah, this has all the new changes for drawing the piece. So there it is. You can't do anything, can't move it around, but it's drawing the piece onto the screen. And you can see the piece is defined here at the top, current piece, that T shape. Really, yeah. So later I'll do the inverse of it, so it'll actually be flipped. Okay, so next step, we got our piece drawn to the screen. So next thing we want to do is actually move the piece around. We want to move it horizontally, left and right. So for this example, I'm just going to do keyboard control. I'm not going to be doing gamepad control or anything like that. When the user presses the left key, subtract 1 from the column. When they press the right key, then we're going to add 1 to the column. Starting out, don't worry about bounds checking. Just make sure you can move it left and right starting out. And then we'll check about bounds later, which I mentioned here. So here's what it looks like. In MonoGame, we're going to get the keyboard state and then the array of keys. And for the key, if the key is left and the key wasn't down the previous frame and it is down now, then we're going to move it -1 column. So I created this method called canMovePiece. So it's just going to move our piece left and right. Check to see if we can move our piece left and right. So we're going to subtract 1 from the column for the current piece. If they press left, they press right, then we're going to add 1 to the column. Okay, so here's the next step in action right here. So we got our T piece up here. So we press left, it moves left. Press right, it moves right. So that's the next step. Just get it moving left and right. And as if you notice, if I go too far over to the left, then it's going to go outside. So we're not doing bounds checking at first. Just making sure we can move it left and right. Okay, so the next step is to make sure that we need to drop the piece after a countdown period. You might want to start out with 1 second. Later on, you'll want to have it variable based on how many lines that you clear. But starting out, just pick a value like a second. And after a second expires, then we're going to drop our piece down 1 row, our piece location down 1 row. So I like using floats, 2 floats, 1 for the amount of time that needs to expire for it to drop down, like a constant maximum value, and then the current countdown value. So those are two separate floats. Then after the countdown expires, then I just add the max countdown back to the current countdown value. And then for each update, we want to subtract off the delta time, the time that's passed since the previous update. We're going to subtract that from the current countdown value. So if the current countdown is less than or equal to 0, then we want to subtract one from the row, which is going to move our piece down. And like I said, add the max. Once we move it down one row, add the maximum time to the countdown. You could just set the current countdown back to the maximum, however you want to handle that. Either add the max countdown value to the current countdown, or just set the current countdown to the maximum countdown. So, following block 6. So here it is in our update. We're going to have our drop countdown right there. So we're going to subtract off game time, elapsed time, total seconds. Then if drop countdown is less than or equal to 0, then we're going to drop it down one row. And then we're going to add on max drop countdown to the current countdown. So I have those two floats up here at the top. Drop countdown, max countdown. And by the way, I did add the current piece row and the current piece column up here. So I set that to 20 and 3. So let's go ahead and run that. So there's our T shape. So we can move it left and right. Still not doing any balance checking yet. But as you'll know, notice after it gets to the bottom, it just keeps dropping. It doesn't actually check to see if it's reached the bottom. But yeah, here's our drop countdown and max drop count. So I have the max drop countdown to half a second. So every half a second is going to drop one row. So that's the next step, just getting it to drop. And I do have the example right here showing it dropping. Then it goes to the bottom of the screen. And the draw is going to be the same. I don't think anything's changed in the draw. So the next step is adding the piece to the board. So, like I said, problem is the piece falls through the bottom of the board. So there's two conditions when you want to add the piece to the board. Any block in the current piece reaches row 0, or if you got the bottom defined as 1, it reaches 1. Or any block in the piece is above a block already on the board, and then it tries to move down again, then we want to add it to the board. When we want to add the piece to the board, then we add all the blocks in the current piece to the board. We just loop through the 2D array and add those to the board. And then we reset the block position to the top of the board, in the middle on the top of the board. One thing to make sure, you only need to check to add it to the board when a piece moves down a row. You don't need to check on every update whether you need to add it to the board, only when it gets dropped. Unless you're doing some weird, like, real-time falling block game, but in general, you only want to check whenever it drops down a row. Make sure that the piece is actually, when you add it to the board, it should be within the board, but like we're not doing balance checking yet, so if you try to add a piece from the current array, and if it isn't within the array of the board, then it will generate an error. Yeah, so this is what it looks like. Our piece is going to drop down. So when it gets to the bottom, it's going to add it to the board. Then set the position back to the top of our current piece. And then it's just going to keep stacking. Then we can move it around. Here's our update. So for every update, we're going to, so like we're doing, we're dropping it on when it reaches the countdown expiration period. So here's where we're checking right here. If current piece is 1 and the current piece row plus I is 0. If it reaches row 0, then we're going to add the piece to the board. So I got a method for adding it to the board. Or else if the current piece in the block exists and there's basically what this is saying, and there's a piece below it on the board. Then we're going to add the piece to the board. Yeah, so if it's row 0, then we're going to add it to the board. Or if, current piece row I must 20. Yeah, and this is where it's checking to see if the piece is above another piece already on the board. Then we're going to add it to the board. Now here's add piece to the board. We're just going to leap through the array of the current piece, and if there's a block at that array location, then we're going to add it to the board at the current row plus the index in that current piece array, comma, the column plus the column index in the array. We're going to set that to 1, then reset the piece location. Okay, let's look at the code, or let's look at the example for that. And following block 7. And go ahead and run this. So you can see our block is still falling. We can move it left and right. Still falling, so when it gets to the bottom, it gets added. Can't rotate or anything yet, but and here's an example. So this is going to fall on top of the other block, and then it gets added. Then we're going to move the current block back up to the top. So yeah, we got stacking going on. So that's kind of the next step in this example. Okay. So the next thing we want to do is to give the user the ability to rotate the piece. So we're going to do a simple rotation. We're only going to let the user be able to rotate it clockwise. So I'm going to, like I said earlier, expand the current piece array to 5 by 5 so it rotates on column 2, row 2. And the formula for rotating at 90 degrees. Now, I think you can actually go and derive this from like the rotation matrix for like 2D graphics, and passing in 90 for the or maybe negative 90 for the rotation value. But it comes out to be, it comes out to be your new row will be J as the column index, and your new column will be 4 or whatever the maximum. In this case, it'd be 5. Or maybe it's 5 minus 1 is 4. So it's going to be 1 less than the maximum minus I, which is the row. So it's J, comma 4 minus I. So then we're going to have a temporary array for the rotated piece. So then we're going to copy that rotated piece back into the original piece array to rotate it. Some extra checks you'll need to make later. Make sure that the rotating piece does not make it end up outside the board, like with some of the long pieces, like the eye piece is straight down. So if you rotate it, it could be possible that you would rotate it outside of the board. So you got to add a check for that. If that happens, don't let them rotate the piece. Make sure the rotating piece does not make it end up inside of a block already on the board. So these are like little tiny things you don't think about. You know, you're always like, hey, this is a falling block game. It's been around forever, and it's so easy. Yeah, this looks like such an easy game to implement, but there's so many of these little small checks. If you don't put in there, then it will end up wonky, and it won't feel right. It'll feel buggy. People will say your game is buggy, so you got to add all these extra little checks for things like rotating the block outside the board, or rotating it and preventing the user from rotating it into a piece that already exists on the board. And that goes the same for moving the piece. You don't want to be able to move the piece into a piece already on the board, or a block on the board, or move the piece outside the bounds. So someone new to game development is like, oh yeah, it just looks simple. You just move it left and right, add one to the column, subtract one to the column, or just rotate it. There's just so many extra little checks you got to do. So yeah, go ahead and run this. So still we only have one piece type, which is the T piece. If we click it there, but if we press up, Now we can rotate it. And it's rotating like this because it's at the center is defined to be location 2-2. Now later on, there's some additional considerations you need to make, because if you have the O piece, the square block, it isn't going to rotate cleanly on a 5x5 array, so you'd have to add some extra checks or dynamically figure out how to get the width or the number of rows and number of columns of the current piece. So I did let this run a little bit just to show we got it rotating. We're adding blocks to the board, but we're still not clearing lines yet. We're still just stacking blocks whenever they collide with the existing block on the screen. And by the way, we're still not checking for game over either. So the next... Yeah, so this is basically just what I was showing, rotating the block. We got our current piece. So I expanded the current piece out to 5x5, just so we rotate on the center. Added the check for when the up key is pressed. We're going to check, is the key down? If it wasn't before down, now it is down, then we're going to rotate the piece. Later on, I added in this can rotate piece. You don't need to worry about that starting out, but later on you'll want to check. So I had a function or method here for checking if when they rotate the piece, whether it's going to end up outside the board or below the bottom of the board. And that turns out to either be true or false. If it's not a valid move, then it's going to turn false, and then it won't rotate the piece. So the next thing we want to check is to clear a line. So after the block has been copied to the board, we want to check all the rows on the board to see if a line has been cleared. So the 1 through 10 in columns for a specific row, if they're all filled with a block, then we want to clear that line, then move all the lines above it, all the blocks above it on the board down. And you can get into some interesting considerations with that. Sometimes you can clear 2 lines or 4 lines at a time, or sometimes you can clear 1 line, the next line you won't clear, and then the line above it is cleared as well. So sometimes you got to add some certain considerations when you're clearing like that. So yeah, if they all have a block, then all the cells in a row on the board have a block. If it's true, then remove all the blocks in that row. So this is kind of like how I logically think through it. I don't think in code. I think in steps. It's when all the cells in a row have a block, then remove all the blocks in that row, then move all the board blocks above it down 1 row. You got to keep a separate row and column counter when you're going up through this. And then if you're tracking score or line count or levels, then you want to add to that whatever values. Yeah, so here's the example right here. So we've got our T block coming down. So when it ends up right here, we're going to move all the blocks down 1 row. So this is when we add the piece to the board in that method right there. We're just going to add, after we've added it to the board, we're going to check the cleared rows. This check cleared rows. So we're going to go through all of the rows, and we're going to have a Boolean, true or false variable, row cleared. So we're going to go through all the column values as J index, and if any of those are 0, we're going to assume the row is cleared by default. But if any of the blocks in that row, if any of the cells does not contain a 1, meaning it contains a block, then we'll say the row is not cleared. So we're assuming it's cleared to begin with, but if there's any gaps in that row, then we're going to say it isn't cleared. So when you're making a game like this, you kind of got to change your way of thinking for some of these. So then if the row is cleared, we're going to go through and delete, set all the blocks in that row to 0. Then we'll have a separate counter for all the rows above. So we're just going to move for all the ones up to row 19. We're going to move those down. That's what this code right here is doing. So let's go back and look at the code, or look at the example. And I'll just go ahead and say, like I said earlier, this isn't going to be like a flashy, pretty game. It's just going to be like black and white, just to show the basics for implementing this falling block line clearing game. So here it is right here. We're still just only working with the T. We're not worrying about any other pieces yet. So as this thing falls, gets copied to the board, and we're going to drop another one. Put it right there. Then maybe put one right on top of it. No, I'll just go ahead and put it right there. Yeah, make this quick and simple. Yeah, maybe put one like here. Now, if I was playing a real falling block game, I would not play like this. Just for the example here. Oh, I might have messed up. Yeah. Let's see here. How can I set this one? Yeah, I can't put the other one in there, so I'll have to make another line. I messed up right there. Let's see here. Put this one here. Then put one in here. Then put one right there. Okay, so here's where we're going to make the line. And I will say, this is how I make games. Is like, I make a change, I see if it works. I make a change, see if it works. So we're going to drop that in there, and it clears the line. So every time I add a new like piece of logic or functionality, I check and see if it works. I don't like, I may not test every single case, but I don't just like code it and then say, hey, it works. So there's another line clearing right there. It's a constant like cycle of making a change, implementing something, seeing if it works. I know some people have said, it's like, oh yeah, do you check and see if your game works as you're developing? Yeah, it's constantly checking your changes to see if they work. I mean, if you're good enough not to test as you write code, then like, good for you. But the way I develop is like, always make a change, see if it works. Okay, so the next thing I think about, and you don't necessarily have to go in this order, but logically thinking this, I could have checked for game over before I checked for cleared line. So it's really up to you what you want to do next. But in this example, the next thing I want to do is check for game over. This might be either easier thing to do. Like I say, checking for game over, easy. When a piece is copied to the board, check to see if the piece block would be copied above the maximum row. If it's above the top of the board, then game over. You've reached the top. Previously, this would cause a runtime error trying to copy a block into the board at an index that doesn't exist, unless you're using a programming language that lets you put blocks at any array. Then you don't have to worry about it. In MonoGame, it does complain if you define the number of rows and columns in your board for that array, and you try to put something in that array at a location that isn't defined, then it will generate a runtime error and crash your game. But in other languages, you might be able to put it at any location you want. So what I do is I just stop game processing and display a message. I usually have like a bool for game over. So set the game over bool to true, and then display to the user that the game is over. Then you can let them retry or redirect back to a main menu or something like that. So yeah, it's pretty easy. When you add a piece to the board, if the current piece plus I is greater than 20. So basically we're checking for every block in the current piece. If that current piece exists, if it's a block represented by number 1. If that current piece plus the row is greater than or equal to 20, then we're going to set that game over boolean to true. And in this case, I created a sprite font for something MonoGame needs to define your font. Load your font and load content, and then we're just going to say if is game over, then we're going to draw game over to the screen. We set the font size to 32. So let's go back to our example. Following blocks 10. And by the way, I think I did define, a bool at the top, an instance variable is game over as to false. And then, I believe an update. Is it update? Could just check for is game over. Is game over to true? Draw. Oh, I guess at this time it still continues to add blocks, or it just doesn't matter because every block is going to be copied above that location. So that's one thing you want to do. If you put one big if around your main update, so that so if the game is over, quit adding new blocks to the screen. Don't let the user continue. That's when you want to, or you could just automatically redirect to a game over screen, then you don't even have to worry about it. So yeah, here's the blocks getting copied, stacking up. So it's important not to check until the block's actually been copied to the board, because obviously the block is above the top. So there it is. Try to copy the next block is above the top row, so we're going to display game over. I don't think it'll, this is where it'll actually let you still continue playing. So yeah, that's where you want to check, and if the game's over, don't let the user control it anymore, or redirect the user to a separate screen. Okay, so here's where it gets to the fun part. Randomizing pieces. So what I did is I created a list of templates, or an array of templates. So I actually have a 3D array, an array of 2D arrays of piece templates. So we're going to have like the I piece, the O piece, the S piece, the Z piece, the L piece, and J piece, and the T piece, and the O piece. I'm already set mine. We're going to have 7 different pieces. So on start, when the game starts, or after a piece is landed, then we're going to generate a random number from 0 to the size of the piece template array. So we're going to get a number 1 through 6 for the 7 different pieces, or 0 through 6 for the 7 different pieces. Get a random number. Then we're going to copy the piece template at that index to the current piece array. So this is what it looks like. We're going to have this big, huge array of 2D arrays for each of the pieces right here. I'm just mentioning again, you go from 0 at the bottom to 1 at the top. So when you define these arrays, the pieces will actually be flipped vertically. It'll be mirrored vertically unless you set the top row as 0 and go to the bottom row as number of rows. But in this example, I got the bottom row as 0, or I think 1, then top row is 20. This is entirely based on your preference. So here's the code right here. We're going to get a random object called R. We'll set that to create a new random, instantiate a new random object. Then we're going to use r.next mod 7. That's going to, r.next is going to generate a random integer. I think it's like 1 to 32,000 or something. So we're going to mod 7 to give us a number from 0 to 6. We're going to store that in IRAND. So variable called IRAND, and then we're going to set all of the values in the current piece to the piece template at the IRAND location, and then we're going to copy that array over. So let's go back to our example. Falling blocks 11. And run this. Yeah, so here we go. Got random. So there's our L piece. We can rotate it. When it lands, it gets copied to the board. So there's our S piece right there. So if you develop this further, you want to add the ability to drop these pieces and add like the ghosting and all that good stuff. The drop location. So right now it's kind of a slow game. It also doesn't have the increased speed or anything as you play through. So there's our I piece. And I think one of the things I mentioned. So here's our O piece. So using that 5x5 array, you still get rotation with the O piece. But when you drop that, clears that row. And if you're keeping track of score, you would add to the score and the number of lines. And display that. And here's another piece. So later on, I'm thinking one of the slides, or one thing you want to do, or if you're developing this further, one of the problems is this gives you a random value 0 to 6 every time. So it is possible to get like 1, 4, 2, 2, 2, 3, 1. So you can get the same piece multiple times. If you play some really early implementations of the falling block line clearing game, you see that. But in later implementations, you see like where they use like a bag, where you generate a list of random ints from 0 to 6. And then you pick from that list, keep picking from that list until it's cleared. And actually, I did a talk a couple of years ago about randomization. I go into how to actually do that. So if you're interested in developing something like this further, take a look at that randomization talk. You can see how I did that. But yeah, that's basically it. A working falling block line clearing game. Really no frills or anything. So yeah, here, the last slide I have here is the improvements. One thing is clearing up the rotation. Like I said, the O block should not move around as it's rotating, but since the O block does not have the defined center of the O block is in the center of all 4 of the blocks, and you can't specify that with an index. That'd be like a 2.5 or something. Adding line count and score. Speed up the game as lines are completed. Add better graphics, sound, different colors, things like that. Like I mentioned, better randomization algorithms using a bag. Add a piece preview. Let the user drop the piece. Oh, and that's one other thing. Whenever you're playing this, you have to press the left and right key down every single time. So another improvement would be to allow the player to move, to hold down left or right, or press left or right on the joystick or whatever, and then automatically move it over. Not make the user have to press the key multiple times. Other things, add a title screen, game over screen. Even further, I did dabble a long time ago with doing some simple multiplayer just between two systems. You could either even do online or add leaderboards. There's just many different ways you can take this. And that's it for the slides. Like I said, I'll post the code out there so people can take a look at it. And maybe if I have some time, I might see if I can. I've implemented this game in like JavaScript and a few different languages, but it would be nice to go back and do like Allegro and SDL and do it in Game Maker and Unity. I've done an implementation in Unity, haven't done one in Unreal Engine, but I kind of consider the falling block line clearing game to be like the bare minimum. Like if you can do the falling block line clearing game, I consider you a game developer if you can do that. I mean, that's kind of takes everything that you need to know to make a game. It kind of combines it into test all those different skills that you need to know to be a game developer. So it's like if I was hiring somebody to be like, which I'm not hiring anybody, but theoretically, if I was creating a team of game developers, I would say, hey, can you make the falling block line clearing game? And yeah, so if you can do that, I would consider you like a competent game developer. But anyway, that's my soapbox on that. I want to go back and mention on the Knox Game Design org website, I did create this graphic for the upcoming Game Jam kickoff, going to be this Friday, April 28th, 2023. That's really slow. So yeah, we've been doing this Game Jam kickoff since like late 2013. So we're just going to be announcing themes, talking about themes, talking about ideas and brainstorming. We're not actually going to be developing game unless somebody just said, if you want to come and show off something you've made, yeah, that's totally cool. But we're not going to actually, unless you just need some help or something, we're not actually going to be making a game on site because we're meeting at Panera Bread, and I think they actually close at 9 or 8. So we might actually be kicked out a little bit early. Still looking at options for other places to meet. Right now, it's still a pretty small group, so you got to consider like how much you want to spend for a meeting location if you're only going to have a few people show up. But hopefully one day we'll grow, have a lot more people, and then we can talk about bigger meeting venues. But yeah, I'm just keeping the rules very simple. The goal is to create a game in 48 hours, but use whatever time you need. Yeah, just post in Discord, or I'll check some of the sites to see what people are working on. And once everybody's created their game, I'll post it to the knoxgamedesign.org, all the ones that have been created. You can make a game based on the theme, or just ignore the theme and make whatever you want. This is really small. I should have... Next time I make one of these flyers, which, by the way, I do have flyers. Yeah, so I did go out and created printed flyers. I have about 10 of these. If anybody wants one, you're welcome to one while supplies last. But yeah, I'll probably start. I've learned a few things while making these. Like I should have made like the background for the text a little bit lighter. I shouldn't have used blue on blue because that's really hard to read. But the idea was like, well, I could post these, like hand these out or post them like local educational institutions or things like that. But I think for now, I'm just going to try to keep it small until we have a bigger meeting location. But yeah, I did learn some things while creating those things that I'd do differently next time. This is also on the knoxgamedesign.org website. Extra challenge, don't use any pre-existing assets, graphics, sound effects, or music. You create everything during the jam. And here's the big one. You're free to submit your game to any other game jam that may be going on at the same time. It's just based on new legal reasons that I've been reading into. We can't say we're associated with any other jams. But you are welcome. Please submit to any other game jams that you wish. There won't be any voting, judging, or ranking, but everybody's encouraged to play each other's games, and you're free to submit your game to any other game jams with voting, judging, or ranking. No prizes. Your game is your prize. Use any game engine or library. I just put some examples. Godot is getting very popular. Unity Game Maker, Unreal Engine, MonoGame, or Allegro. And see Knox Game Design for further details. So you can get a Knox Game Design. That's really big. And you can get the information right there. So yeah, hopefully have a lot of people come out. Some people come out and talk about making. Really, we just get together to kind of just like friends getting together, talking about old times and game ideas and brainstorming and things like that. So it's really not structured and everything. So don't show up feeling like you need to be expert game developer to show up. And oh, by the way, people can show up and not even make a game. If you just want to come out and talk or whatever, that's fine too. Don't feel like you have to make a game to show up. So that's all there is to it. Yeah, we try to do this twice a year, 2 or 3 times. Yeah, usually twice a year. It's been kind of hard past couple of years getting things, but we're trying to get back into the swing of things and things like that. So anyway, that's going to be it for April 2023. Hope everybody's doing well, and we'll try to be back in a month.